Now that we have a fundamental understanding of the different target setting methodologies and opportunities available, I want to talk through an example with our example company, Formula Pharma. For this, we'll focus primarily on scope 1 and 2, but we will touch on scope 3 for a little bit. So you probably remember Formula Pharma, and let's walk through together the process of scope 1 and 2 target setting for this company. On the left, you can see a recap of the company and some context that might be helpful to remember. Formula Pharma is in the healthcare sector under pharma, biotech, and life sciences. They have 18,000 employees with $10 billion annually in sales. They're an international organization with their headquarters in New York, but also have offices in Germany, Singapore, and Australia. They're an innovative drug manufacturer in the respiratory and cardiovascular disease category, and they mainly work with API suppliers, chemical and biological suppliers, as well as packaging suppliers. Their primary customers are wholesalers, distributors, and hospitals. We have a breakdown of their scope 1 and 2 emissions on the right-hand side, which they had calculated and broken down into both scope 1 and 2, as well as a breakdown of all of their emissions. You can see that 71% or 25,000 metric tons of CO2 come from their electricity use, while the remaining scope 1 emissions come primarily from natural gas, making up 21%, with a small portion of fleet and refrigerant leakage emissions as well. Let's talk about how they set a target. When selecting a target setting approach for scope 1 and 2, Formula Pharma found that absolute contraction is the most suitable methodology because they don't have the opportunity to set an SDA or sectoral decarbonization target as a biotech and pharma company. Having come to that conclusion, you can see that Formula Pharma came out and modeled what their required reductions would be for scope 1 and for scope 2. One thing that they needed to decide on is which year they wanted to use as their base year. They've decided to use 2021 as a base year since that's more than 3 years, or since that's more than 2 years in the past. They need to use 2024 as their most recent year and have selected 2030 as a target year. You can see their scope 1 and 2 emissions broken down across those 3 years in the table on the left, as well as the total reduction required to align with that 1.5 C scenario. You can see on the right-hand side that those reductions are at 42% across scope 1 versus scope 2. It looks a little bit steeper for scope 1 versus scope 2 because they have a greater portion of scope 2 emissions than scope 1 emissions. And you can also see that their most recent year really keeps them on track for the emission reductions required. Now that we understand that absolute contraction approach, I want to use our other example, Apex Medical Supply and Device Company, to talk about the sectoral decarbonization approach. Apex Medical Device and Supply Company has an SDA option because they are included in the chemical sector. They have 22,000 employees with $12 billion in annual revenue. They're mostly located in North America, Asia, and Europe. Their product portfolio really includes medical and surgical products and supplies with private label manufacturing and packaging. Their suppliers are primarily raw materials packaging suppliers and medical manufacturing suppliers, and their customers are wholesale distributors, hospitals, pharmacies, and physicians' offices. You can see their scope 1 and 2 emissions breakdown from their base year of 2020 with 3,000 tons of CO2 equivalent in scope 1 and 12,000 in scope 2. Because they are considering this SDA approach for sectoral decarbonization, they've also looked at their 2020 emissions intensity, which is 0.3 for scope 1, 1.2 for scope 2, which nets out to 1.5 across scopes 1 and 2. So since they have the option to set either an absolute reduction target or a sectoral decarbonization approach and reduction target, which would be more of an intensity target, we want to look at how those can be compared. So in the table on the upper right, you can see both an absolute contraction approach and a sectoral decarbonization approach. The bolded numbers are the reductions provided by SBTI. So for absolute contraction, they would be required to reduce their scope 1 and 2 emissions by 42%. That's what's provided. SBTI would require that they reduce their emissions intensity by 75% in an SDA approach. And it's important to consider how those are relative to one another. And so we can translate absolute emissions to emissions intensity by looking at the relative absolute emissions required to be reduced in both scenarios. So while a 75% intensity reduction looks like a lot more than a 42% absolute contraction reduction, when you translate it back, the sectoral decarbonization approach would actually require a 63% reduction in intensity terms, whereas an intensity target would require 71% reduction in intensity. And so we need to compare apples to apples to see that the absolute contraction required approach requires less of a reduction than SDA. So they may consider moving forward with that.